نحن كنا حكينا عن البروجكتايل موشن. جبنا الايكويشنز اوف موشن، جبنا الاكس as function of time, y as function of time, vx as function of time, vy as function of time. وهلا صرنا قادرين نفهم كل شيء عن الموشن. واول شيء هي الايكويشن of trajectory or the path followed by the projectile during its motion. كلكم تعرفوا من السنين اللي قبل انه trajectory will be a parabola، بس رح نشوف نحن ليه هو parabola. تذكروا انه البارامتريك equations هن x equals v0 cosine theta 0t plus x0 وال y equals minus half gt square plus v0 sin theta 0t plus y0. شو بعمل؟ بجيب التايم من اول equation، بيطلع معي x minus x0 over v0 cosine theta 0. من بعد ما اجيب التايم بحطه بالايكويشن اللي هي فيها y، بيطلع معي minus half g x minus x0 v0 cosine theta 0 square plus v0 sin theta 0 x minus x0 v0 cosine theta 0 plus y0. شو بكون عملت أنا؟ بكون طلعت equation أو relation between x and y time independent. هيدي هي equation of motion أو equation of trajectory. هي by definition it's a relation between x and y independent of time. So صار معي هيدي relation which is y equals minus half g over v0 squared cosine squared theta 0 x minus x0 squared plus tangent theta 0 x minus x0 plus y0. هلا إذا launching the projectile was from the origin which is 0 0 يعني ال x0 كانت معي 0 وال y0 معي كان 0, so the equation of the trajectory will be reduced to a simpler form which is minus half g over v0 squared cosine squared theta 0 x squared plus x tangent theta 0 which is an equation of the parabola. كلكم تعرفوا انه البارابولا هو عبارة عن function عنده equation y equals ax squared plus bx plus c. so هون هيدا الترم اللي أول شيء هو ال a which is multiplied by x square and tangent theta 0 is the b which is the term multiplied by x وال c هون بالنسبة لي كان 0. you can see clearly that a عندي هون is negative which means that my parabola is upside down. يعني هو عنده peak ما عنده maximum ما عنده minimum. okay, which is obvious in the case of a projectile. After finding the equation of motion of a projectile, let's find the range. Okay, the range is defined as the direct horizontal distance measured between where the object was launched to where it reaches. So إذا أنا عندي projectile is launched from the origin O, the range is the distance, is the horizontal distance along x-axis. As you can see, this is the range. Okay, it's the range R. If the particle is not launched from the origin, it's launched from another point. Assume it's launched from this point here. This is the origin where it's launched. This is the origin of the Cartesian coordinate system. So رح تعمل particle, for example, a parabola. The trajectory of the particle will be a parabola. الرينج وين صار بهالحالة؟ الرينج هو it is the horizontal distance measured between the object from where it was launched to where it reaches. Okay, so this is the range. If I take the special case where x0 is equal to y0 or the projectile was launched from O، يعني أنا زتيت البروجكتايل من ال O، اوكي، او اخترت انا الكارتيزيان سيستم اللي هو الاكس او واي تعولي من محل ما بلشت الموشن للبروجكتايل. بهيدي الحالة انا بضمن انه الاكس 0 والواي 0 يكونوا زيروز، وبهيدي الحالة الايكويشنز بخفوا شوي. So I will use the equation that I have already found or the trajectory equation that I have already found in the previous slide. طلع معي y equals minus half g over v0 squared cosine squared theta 0 x squared plus x tangent theta 0. هيدي الايكويشن للتراجكتوري رح اخدها، وانا بعرف انه لما البارتيكل توصل على الاكس axis its y will be 0, so I will try to solve this equation when it's equal to 0. وبلاقي الاكس اللي بلاقيها هن they are the solutions for when the particle crosses x-axis. We get 0 equals x into minus half g v0 squared cosine squared theta 0 x plus tangent theta 0. So either x is equal to 0 or the other bracket is equal to 0. X equals 0 is the solution at O. He already أنا بعرفه إنه for x equals 0 y is equal to 0 because I have chosen the case where the projectile is ejected from the origin. The other one, the other bracket equals 0 will give me x equals tangent theta 0 over half g v0 squared cosine squared theta 0. Simplifying, I will get x or r, which is the range, equals v0 squared sine 2 theta 0 over g. Remember that I have used the equation or the relation 2 cosine theta 0 sine theta 0 equals sine 2 theta 0. So this relation 2 with cosine theta 0 sine theta 0 is equal to sine 2 theta 0. I've got a relation for r. في طريقة تانية بقدر أنا ألاقي فيها الرينج باستعمال البارامتريك equations. When I say parametric equations, I mean x as function of time and y as function of time. لحتى ألاقي الرينج which is r, I have a condition إنه لما توصل البارتيكل على الرينج بيكون ال y is equal to 0. So I will take this, I will put y which is a function of time equal to 0. بطلع التايم، من بعد ما طلع التايم باخده بحطه بالاكس I will get x which is the range. Okay, so what we'll do is that we will use the equation of y as function of time which is equal to minus half gt square plus v0 sine theta 0 t. I will put it equal 0 and I will try to solve for t. بيطلع عندي two solutions for t. t equals 0 هو الوقت اللي أنا بلشت فيه الموشن and for sure it was at O. أنا مش هيدا اللي عم فتش عنه, it's not the range. The other solution for t is equal to v0 sine theta 0 over half g. It will give me 2v0 sine theta 0 over g. لقيت التايم, من بعدها باخد التايم وبحطه بالاكس. In this way I find r. Substitute. Remember that the equation of x as function of time was v0 cosine theta 0 t. So substitute for t as I have done. بتلاحظوا انه بيطلع معي I will substitute and I will get 2v0 squared cosine theta 0 sine theta 0 over g. وأنا رح أعوض 2 cosine theta 0 sine theta 0 بقيمتها اللي هي sine 2 theta 0. So I will get this form. Okay. You can see that this answer is the same as the range found from the previous method. They are the same. I'm using the same condition y equals 0 and I'm searching for x. Okay. بالطريقة الأولى دغري ربطت الواي بالإكس ما استعملت التايم. بالطريقة الثانية ربطت الواي بالتايم والتايم بالإكس لحد ما لقيتها. طيب السؤال هو إنه أنا كيف لازم اختار الثيتا 0 لحتى الرينج يكون ماكسيموم, لحتى خلي الرينج يكون أكبر شيء ممكن, assuming that I'm always throwing with the same v0. r is maximum when sine 2 theta 0 is maximum. The maximum of sine function is 1. So solving for sine 2 theta 0 equals 1, I will get 2 theta 0 equals 90 and theta 0 is equal to 45 degrees. هيدا بيعني انه انا لحتى خلي البروجكتايل تقطع مسافة طويلة لازم زتها ب initial angle 45 degrees. So I will get a range substituting for sine 2 theta 0 1. I will get a maximum range of v0 squared over g. When you solve, you can see that complementary angles will produce the same range. Why? Because sine 2 theta 0 for complementary angles is the same. So if I'm calculating sine 2 theta 0 for theta 0 equals 30 for example, and for theta 0 equals 60, I will get the same answer. If sine 2 theta 0 has the same answer, then these two angles will get the same range. This figure explains better what I'm saying. So let's move to the next slide. You can clearly see that the maximum range occurs for an initial angle of 45 degrees or theta 0 equals 45 degrees, which is the parabola drawn in red. You can also see that complementary angles, for example 60 and 30, which are the blue and the green, parabolas, they have the same range. They are complementary. Their addition is equal to 90. Similarly, 80 and 10, they have the same range. They are complementary. The last topic in the projectile motion is finding the peak or maximum height. Maximum height reached by a projectile. As I have already explained that at the peak Vy is equal to 0. Vy بتكون 0 لأنه ال Vy هي المسؤولة عن motion of the projectile upward or downward. لما توصل البروجكتايل على البيك بتبطل قادرة تطلع طلوع, so its Vy will be equal to 0 at this stage. Okay, so I will take this condition and try to find from the time equation of Vy the time. Take this time, substitute this time in y because I'm searching for a height, so y is the height. Substitute time in equation of y as function of time and get the maximum height. We have took the equation of y of Vy. We have took the equation of Vy as function of time, which is minus gt plus V0 sine theta 0. We've placed this equation equals to 0 because at the peak at top بتكون Vy equals to 0. We have found the time, t it's equal to V0 sine theta 0 over g. Before I continue, I will note that هيدا الوقت طلع معي إذا بتلاحظوا أنتو نص الوقت طلع معي when I was calculating the range. لما كنت عم أعمل calculation للرينج طلع معي time equals to V0 sine theta 0 over g. هيدا بيعني إنه البارتيكل خلال الموشن تاعتها قد الوقت اللي بتاخده بالطلعة هو ذاته الوقت اللي بتاخده بالنزلة. لقينا التايم هلأ رح اخد هيدا التايم ورح حطه بقلب الايكويشن للواي كرمال اقدر اجيب الهايت. So y equals minus half gt square plus v0 sine theta 0t. I've substituted everything. Okay, I have tried to make some simplifications. I will get minus half v0 squared sine squared theta 0 over g plus v0 squared sine squared theta 0 over g. So minus half plus 1 بيطلع معي half v0 squared sine squared theta 0 over g. This is the height for a certain projectile. If I'm trying to search for the maximum height, in this case I will try to make sine function equals to 1 because this is the maximum for the sine function. If sine theta 0 is equal to 1, then theta 0 will be equal to 90 for sure, and then h max will be equal to half v0 squared over g. Now, sometimes describing the motion in the Cartesian coordinate system in can x or y or x or y z in 2 dimensions or in 3 dimensions is sometimes not helpful in understanding the motion. So there is a new frame of reference which was invented that helps us understand some motions such as circular motion. This frame of reference is called Serret-Frenet system. So this Frenet system is different from the Cartesian coordinate system in a way that it is not fixed. This frame is variable. Assume we are going to replace the Cartesian coordinate system OIJ by the Frenet system MUTUN. O, the origin, is replaced by M, which is the position of the particle. I is replaced by UT and J is replaced by UN. So UT and UN are the new unit vectors instead of I and J. Because UT and UN are unit vectors, their magnitude is equal to 1 and they are perpendicular. The unit vector UT is always tangent to the trajectory, and the unit vector UN is drawn perpendicular to UT towards the inside of the curve. So keep in mind, always UT is tangent and UN is directed towards the inside of the curve, لجوات الكيرف مش لبراته. If you look to the figure, you can see that the Frenet frame of reference is attached to the point M such that UT is always tangent to the trajectory and UN is directed towards the inside. As M moves, the frame of reference or the Frenet frame of reference moves with M, okay, such that UT and UN have changing directions. The direction of UT is changing with time, and the direction of UN is also changing with time, which means that UT and UN, they are not constant vectors, they are variable vectors. Their directions are varying as function of time. This leads us to a conclusion that the finite frame of reference is not a fixed frame of reference, neither in position nor in direction. At the beginning of the chapter, I have said that we are studying the kinematics of motion. That is, studying the description of motion, or how to describe a motion. We have arrived to a result that in order to fully describe a motion, we have to determine the position, the velocity, and the acceleration. These three quantities were determined in Cartesian coordinates. تعلمنا كيف نعمل position, velocity, والacceleration بالCartesian coordinates. We are going to learn how to determine these three quantities in finite frame of reference. For the position, we are no more going to consider a vector. Instead, we are going to choose an origin O on the trajectory of motion, this is O, and we're also going to choose a positive sense. The particle is found at a certain instant at a point M on this trajectory. So the position of M is determined by the measure of the arc OM. The measure of this arc is called the curvilinear abscissa. That means abscissa on a curve, the length of this curve. So S, actually, the abscissa or the curvilinear abscissa is the arc or the length of the arc OM. For sure, if M is found to the right, then S will be positive. If M is found to the left, S will be negative. S can be positive or negative depending on the position of M. Remember that S is not a vector, it's just a measure of a length on a curve and its unit is meters. I have already said that velocity vector is always tangent to the trajectory, and since we have already seen that for finite frame of reference we have two unit vectors, one of them is tangent to the trajectory. So if I'm planning to write V in terms of finite frame unit vectors, I must write V vector equals V ut, where V, which is the speed, is the magnitude of the V vector. V, or the speed, is equal to ds over dt. Why? Because as I have already said, the speed is defined as the distance over time. So here, s is the distance, it's the real distance. So if v is variable, it's not constant, I cannot divide s over t. I have to take into account small variations. I will say v is equal to ds over dt. I have already explained the position and the velocity in finite frame of reference. Now I'm going to explain the acceleration in finite frame of reference. A vector is the derivative of the velocity vector, as you can see. So what I'm going to do here is that I'm going to derive v prime. I'm going to derive v in order to find a in terms of the finite frame unit vectors. So deriving this, I will get v prime ut plus v ut prime. Remember that ut is a unit vector which is variable as function of time. As long as the particle is moving, ut will change لأنه هي دايما tangent. كيف ما بتمشي البارتيكل ut بتمشي معها, so it's variable. I have to derive it. Given ut prime equals v over r un, no need to know the proof. So we will get a equals dv over dt, which is v prime ut plus v square over r un. I have substituted here for v over r un, and I will call this component multiplied by ut at and the component multiplied by an un. So we will get these two components. You can see that a in finite frame of reference is composed of two components. A normal component, or we can say it's a centripetal component, and a tangential component, which is AT. The tangential component is equal to dv over dt or v prime. Remember that v is the speed, هي السبيد منا velocity, and an is the normal or the centripetal acceleration, which is equal to v square over r. And r is the radius of the curvature. Radius of curvature means that at a certain point, for example here A, the position where A lies, it belongs to an arc. This arc as if it is a part of a circle of radius r. This radius r may vary as the particle moves on a certain trajectory، لأنه كل نقطة بتكون فيها البارتيكل بيكون عندها انحناء غير الانحناء اللي بيكون موجود في مناطق بتكون flat, more flat، في مناطق بتكون أكتر منحنية. So this bending in the curve okay بيعطيني فكرة عن ال R. So when I find R at a certain point بقول أنا بهاللحظة الفلانية كانت البارتيكل موجودة at a certain instant at a certain position at a position where the arc has a radius or radius of curvature r. So the arc where the point is found as if it belongs to a circle of this radius. The magnitude of acceleration is a equals radical at squared plus an squared. I can use this to find the magnitude of the acceleration. If you look at the figure here, you can see that A can be decomposed into two components, AT and AN. AT ولا مرة بنرسمها لبرات الكيرف، دايما لجوات الكيرف بتكون مثل ما لاحظين حسب الانحناء بتكون لجوات الانحناء. So AN and AT, AN is towards the center and this is it varies according to the motion of the object. But anyway, A is composed into two components, AT and AN. اوكي نحنا قلنا انه ال AT equals V prime. كل مرة بتكون السبيد constant derivative تاعه لزيرو يعني ال AT زيرو. So ال AT بتعطيني فكرة if the object is accelerating or not. اوكي ال AT بتفيدني لأعرف إذا الموشن is uniform or not. Is it a uniform rectilinear motion? Is it a uniform circular motion? Is it a uniform motion on a parabola for example? كل مرة بتكون ال AT زيرو هيدا بيعني إنه السبيد constant، هيدا بيعني إنه الموشن is uniform. ال AN بتساوي V square على R. كلنا بنعرف نحنا إنه for a straight line بيعتبر circle of radius infinity. So for a straight line AN equals V square over infinity, it will give me AN equals 0. So ال AN بطبيعتها تعطيني فكرة إذا الأوبجكت عم يعمل bending أو لا. If the object is moving on a straight path, AN is equal to 0. If object is bending, then AN is not 0. So these two parts of the acceleration, which are AT and AN, give me very important information about the motion. ال AT بتخبرني إذا عم يسرع عم يبطئ أو ماشي بسرعة ثابتة. ال AN بتخبرني إذا عم يعمل bending أو ماشي على straight line. So whenever AT is 0, then the speed is constant. Whenever AN is 0, it means it's moving on a straight line. The last topic I'm talking about is circular motion. We can describe circular motion using Cartesian coordinate system. We can describe circular motion using finite frame of reference. But sometimes dealing with angles makes more sense. يعني when I tell you that that the object has moved an angle of 2 pi, directly you will imagine that this particle made one turn of a circle. So sometimes it's good to explain everything in terms of angles, especially when we are dealing with circles. So مثل العادة in kinematics, to describe fully an object, we have to determine 3 things: position, velocity, and acceleration. Now we're going to learn these 3 things, but in terms of angles. Suppose that an object moves on a circle of radius r and a center O. The object starts from P and travels a distance ds along circle sweeping an angle d theta during time dt. إذا البارتيكل بلشت موشن من ال P وصارت على ال Q, so length of the arc PQ هو ال curvilinear abscissa S. كلكم تعرفوا إنه في relation between S and theta, which is S equals R theta. S is the curvilinear abscissa and theta is the angle. Okay, so first we can determine the position in terms of the angle, which is theta. Theta is equal to S over R. From the Fresnel frame of reference, we have seen that the speed, sometimes we call it a linear speed to emphasize that this speed is along a curve. So the linear speed of the particle will be v equals ds over dt. So we are going to define the angular speed, which is theta prime or omega. Omega is equal to d theta over dt, which is the variation of the angle as function of time. The unit of angular speed is the radians per second. Okay, so there's a relation for sure between v and omega, which is the speed, linear speed, which is in meters per second, and the angular velocity, which is in radians per second. The angular velocity sometimes is called angular speed, but ما بيعملوا فرق ما بين angular velocity وال angular speed in books, so it's okay to say angular velocity or angular speed. So the angular speed is the radians per second, يعني كم راديان بتمشي بالثانية الواحدة، بينما linear speed كم متر بتمشي بالثانية الواحدة. Is there a relation between linear speed and angular speed or angular velocity? Yes, because if I'm going to apply this formula, v equals ds over dt, and ds, it's equal, r is constant, it's equal r d theta over dt. d theta over dt will give me theta prime or omega, so I will get v equals r omega. V is the speed or the linear speed, and omega is the angular speed or the angular velocity. Now we can define the angular acceleration. قد ايه عم يزيد سرعته بالثانية. How much radians per second عم تزيد السرعة. So it's theta double prime or نحن بنسميها alpha. Okay. Is there a relation between alpha والاشياء اللي بنعرفها نحن بفرنت؟ Let's relate them. So alpha, let's relate AT with alpha. AT equals dv over dt. الفي كنا نحن جايبينها قبل أو كاتبينها it's ds over dt. Okay, and ds we have already known that it's rd theta. It will give me r is outside the derivative. I will get second derivative of theta over dt square, which means that this is theta double prime, and I will get AT equals r alpha. That means alpha is related to AT and not to AN. Okay, so these are the formulas that I have to keep them in mind. One of the important circular motions is uniform circular motion. بالuniform circular motion بيكون عندي السبيد constant، يعني ماشي البارتيكل على السيركل وسرعتها ثابتة. هيدا ما بيعني انه الفيكتور v constant. الفيكتور v ما بتكون constant لانه هو ماشي بتكون الفيكتور v always tangent to the circle, so the vector is moving in direction، اتجاهها عم يتغير، هو عم يمشي، بينما السبيد is constant، طول الفيكتور بيكون ثابت. So in this case AT is 0 because the speed is constant. ما تنسوا أنا خبرتكم لما يكون الشيء عنده سرعة ثابتة بتكون ال AT تاعته 0، بس هيدا ما بيعني إنه ما عنده A، ما عنده acceleration، لأنه عنده AN. وتذكروا دايما إنه لما نكون عم نعمل bending عم نمشي على circle يعني في AN، وال AN قيمتها V square على R. So in the case of circular motion, AT is 0 and AN is not 0, it's V square على R. So ال A vector كلها هي ال AN vector، هي V square على R UN. The equations of kinematics للuniform circular motion ما رح أعملهم derivation. They look similar to those of URM. بال URM كان معي A constant A0 v constant x equals at plus x0. هون رح بدل بس الالفا، رح بدل الاي بالالفا، رح بدل الفي بالاوميجا، ورح بدل الاكس بالثيتا. بيطلع معي alpha equals 0 omega equals constant and theta equals omega t plus theta 0. Same equations أصلا same proof but I did not include it in the presentation. كمان في عندي شيء مهم بالmotions of circular motion اللي هو uniformly varied circular motion. هيدا امتى بصير؟ لما يكون عندي constant angular acceleration. So alpha is constant. هيدا بيشبه uniformly varied rectilinear motion, but we are going to replace a by alpha, v by omega, x by theta. بيطلع معي هالايكويشنز اللي احنا شفناهم كمان قبل. بيطلع معي alpha equals constant, omega equals alpha t plus omega 0, theta equals half alpha t square plus omega 0 t plus theta 0, and omega square minus omega 0 squared equals 2 alpha theta minus theta 0.